Hello there guys, welcome back to the e-bike repairs YouTube channel. My name's Darsh and I take apart and fix super fun and exciting stuff. Today I've got in this is a SmartDrive max mobility SmartDrive, and the model is a MX2. Apparently this is an MX1 that's been upgraded to an MX2, whatever that means, I don't know. All I know is the battery's dead. What it looks like we've got here is a bog standard e-bike charger, just there, but 43.8 volts, which seems a little odd. Not standard. And then we've got I believe this is a Rosenberger connector on the end. It's like a magnetic jobby that fits in under the charge port just here, like that. And if we plug it in to the mains, we get a light. Just a green light here, no red light. So it won't take a charger, and this won't turn on unless the charger is plugged in, unfortunately. Not entirely sure how this thing works. Perhaps there's a remote or something. Doesn't seem to do any assistance all by itself. I'm not entirely sure quite how it goes. But yeah, anyway, the charger stays green. It does not go red. It clearly is putting out voltage because this turns on and thinks it's got full charge. But if I unplug that, turn it on, we get nothing. So the battery pack inside is dead. The customer has asked me to open it up and see what's going on inside it. If the battery pack is something I can repair or rebuild, probably rebuild, it's been sat for a while. So I see on the bottom here we've got 1, 2, 3, 4, 5, 6 big screws. They look like Allen heads. Let's see. Is this box? Right, they look like Allen heads, and I think they are going to be that size? Yes. This is a 3mm Allen head. So let's pop these 6 out and see what we're working with. 1, 2. That's what they look like. They just look like brake disc bolts from a bicycle, so I think that's M4 or M5 thread, and that tinny little Allen key bit on the end. It's hard to see, and this thing doesn't sit upright. There should be 3 of those to come out. I had 1, 2. We've got 1 left. 1's hanging on. Where are we? This one here. Nope. It's not interested. There we go. Freedom. Right. Let's put that over there, shall we? Does it just pop apart super easily? Oh yes, it does. Look at that. Someone intelligent made this. Okay, case-wise, we've got, that's a lovely, just a strong case. That's nice. That feels good. There don't seem to be any markings to indicate what material it's made of, but it's clearly like a reinforced plastic of some kind. It doesn't sound like it's got glass fibre reinforcing it. When you cut it, it doesn't make a crunchy sound. We've got here what appears to be a bog standard hub motor, but with a custom flange bolted onto it or screwed onto it. And the flange has these little wheels that can go that way, and also then it rotates either that way or that way. It's a geared hub. I can hear it because one way, free spins, so it's free wheels, and the other way, you can hear the gears winding. There's nothing actually locking the axle in? How's that possible? Oh, there is. So the axle itself is held into by a plate that goes around the axle and then to these bolts here and here, which is bolted to, I'm assuming, some, what do you call those? They're not riv nuts. Threaded inserts in the plastic here. So that's interesting. And then battery pack wise, we've got a little buzzer here. We've got our 3 phase wires and our 5 hall sensors and our speed, so 6 wires coming from the motor here. That's all fairly standard stuff. If you damage the cable, I'm sure I could replace that, replace a hall sensor, something like that. I'm sure it's doable. Probably a bit of an adventure taking all these screws off, but that's fine. We've got a reasonably custom board here, which has got, from the Rosenberg connector, we've got all the communication wires are present, unfortunately, for charging it. That's interesting. But in terms of the actual output wires, there's only these 2 that go to the battery pack itself. So the battery pack itself looks like a dumb battery pack, as it were. You know, doesn't appear to be smart functionality. We've got our on-off switch on over here, which goes straight to the board. Looks pretty good. I'll give you a slightly closer up look. Up there, we've got a series of dip switches here. No idea what they do. Big cap. MOSFETs right down the bottom of the board there. It's obviously a custom board to do whatever it's designed to do. I mean, obviously it's a mobility assistance device is probably the correct term of phrase here, but I can tell you exactly what it's supposed to do. Don't know. So what I'm going to get is my multimeter, which I've definitely not lost. It's here somewhere. I found it. And let's do a couple measurements, shall we? Let's look at the voltage coming in the charge port. I'm assuming it's not powering up backwards through the BMS, unless it is. Okay, it's giving 43 volts to the board here, but then, was it nothing down the charge port? Is that what it is? I don't know. Nope, and 43 volts down there, down the charge port. This seems to be dropping off. Yeah, okay, so no voltage is coming in from these wires here. That's fine. It only seems to be coming down the charge port wire. There you go, I heard a little click there. Okay, and then if I disconnect this, is that important? Is it important? Apparently not. Fair enough. I suspect this plug doesn't use the comms wires. It looks like a standard e-bike charger. 43.8 volts is a weird voltage level, but we'll get to that. We'll get to that. Okay, so it might be that that's a comms port or something to plug into, so not only for charging but also for communicating. Maybe they can plug it into a computer or something like that. So let's get this battery popped out of here. So we've got one connector here. There is a built-in inline fuse here, but I doubt it's blown. We've got a piezo here, little speaker, and then to get the battery case out, we're going to have to undo this clip here for the hall sensors, this clip here for the motor phase wires, which is locked in some fashion that I don't know how. I'm unfamiliar with this connector. Have a moment to look. Is it a squeezy one? Is it just a pulley one? I think it's just a pulley one. And that feels like it's not just a pulley one. It's just a pulley one. It's a Molex connector. A bit like you get on a PC power supply. Oh, and I found waterproofing rubber seal. So I do not want to mess up. That will be a pain in the bottom, that will. Let's get that poked back in there before it comes out too much. for me to deal with it. Don't come out, stay in your hole, boy. Okay, fine, well, need to address that a bit more. Right, I can now get to some of the screws. We've got to disconnect. It's going to make it easier if we disconnect the communication from the Rosenberg charge port. It's going to make it easier if we disconnect this little board here that goes up to the lights, and the power cable has got to come out for the battery, and the switch wire has got to come out. And now we can get to the 4 Torx head screws that hold the battery cage in place. So around the battery pack there's this plastic cage. And what size is that going to be? It's going to be a, let's go for T20. Let's try T20. It fits well. That's what we're going with. I'm going to unscrew these 4. Hopefully I can get you a bit of a view of me doing it. It's a bit hard to see in there. So these are threaded, as opposed to screws, they're sort of bolts, because they go into threaded inserts. And it looks as though the speaker is going to come off with the cage. Yep. The bolts have come off with the cage as well, and we've got some rubber vibration dampening washers involved in the situation. Quite a lot of those have just stayed in place, which is nice. If I take out the screws, 1, 2, that's an M4 screw if I've ever seen one, isn't it? Bit Loctite. 3, and oh, there goes 4. 4 of those. I can then pop the battery out because the case has a little clip just here. So that side, I've unclipped that. And this side, I'm guessing, has another clip. There you go. That's the on one side of the cage. And the battery pack's just going to slide out, and I don't have to disassemble everything completely. Oh, I kind of have. It turns out I kind of have. Well, that's the... Give you a close-up of this circuit board now. So I see... Let's point at it with a big metal screwdriver. That looks like it might actually be a SIM card. No, it's not a SIM card. That's for connecting to an app. That'll be some kind of sort of Bluetoothy chip or Wi-Fi chip or something like that by the looks of it. These will be our FETs for driving the motor phase output. I don't know what that thinks it is. Maybe that's the shunt there. We've got our big cap, we've got our dip switches that I don't know what they do. Connectors. Not a lot going on here. Oh, it's double-sided. There's loads going on the back as well. I'm not going to get into that because I don't want to, and I don't have to. So, yeah. Right, this is going to go off to one side. It would appear that this gives out charging voltage. Yep, 43.7, even when it's not connected to this part, so it probably doesn't use the communication wires, but we'll might pop the charger open and have a bit of a looky at that, shall I? So get the charger unplugged, and we'll let that all power down. Move that boy over there. Right, meat and potatoes, 36 volt, 3.4 amp hour lithium ion battery. 2016 is the date code on this. No brand names or anything like that. So, what have we got going on inside? Slicey, slicey, slice, slice. So we've got a layer of blue heat shrink first. That's coming off. We've got a layer of fish paper. The red stuff, not the green stuff. Great, it's sticky. I suppose it's better than it not being sticky. Peely, 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 peely. It's very exciting. Okay, we are nearly there. Get that lot in the bin. In the bin. Okay. Right, we've got our BMS just under here, which looks great. There's no markings on it, but it'll be hopefully a 10S. IC separate. Common port, charge and discharge, so that's why it powers up. The charge is coming in through the through the P minus, not through the. There's discharge there. What do you say? It's really hard to see underneath all this. It definitely says P minus, discharge minus, and B minus here. So the discharge minus is not even being used. So it might be that this isn't adequately protected. I don't know. Anyway, in terms of what's wrong, I see a leaky cell. A leaky cell. And on this side, well, I'm not going to be reusing that, am I? So I might as well just cut this off so you can see. Okay, right. And on this side, another leaky cell. Unfortunately, that will have killed it. Also, given this says 2015 on it inside here, it's even older. We've probably got some very dead cells. How many JST connectors have we got? 1, 2, 3. I'm looking for 11, ideally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What? What have we got 13 for? What does it think it's doing? To have a bit of an investigate about this, won't we? 1, 2. Start this end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So is it 12S? It can't be 12S. What have we got going on here? We've got our plus and our minus, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's weird, they look like normal 18650s to me. LR1865EH, FK04001732, that'll be the serial there. They definitely look like normal 18650s. So why would it be a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? Why would it be a 12S config? And why, if it's 12S, is it not getting charged to 12S voltage? You're getting charged to 43.8 volts. That's weird, isn't it? I've got a sneaky suspicion, from what I've heard anyway, that these batteries can be replaced basically just a hoverball battery. So we could go 10S in here, not 12S, and probably just replace the charger output with something usable. So what I need to do there is see if those pins, the extra pins on here are actually connected, because 43.8 volts is too high for a 42 volt system, if that's what I wanted to put in there. So let's pop open the charger and see what's actually connected. Oh no, it uses those evil triangular screws. I hate them. They are the stuff of the work of the devil. Can't do it with this nice flat head I've got in my hand. Obviously not. Right, what size are you? That size? No. Are you that size? Oh, this size will work. Got to really put a lot of pressure on that. 2, 1 even. Like that, make life easier. Right. I hate these triangular screws. Horrible things they are. Oh, I've stripped one out. Great, go me. That one's a bit bigger. Let's try one size up. That's a no. I think, unfortunately, I'm using the right size bit. It's quite frustrating. It's a stupid design. I hate them. They're not going back in. I'm finding something else. Oh, I think I've got it. It comes at the cost of destroying the palm of my hand from pressing down quite so much, but I think I got it. Right, moment of truth. Oh look, they're not bloody connected. Yes! Right, that's good news, because that means then that this out plus and out minus isn't important. I believe there is a voltage pot on most of these that you could actually trim down the voltage with. So, see through this hole just here, my screwdriver, see what you can see. Just in there, there's a little output pot, and I believe you could use that to trim down the output voltage to make it say 42 volts, not 43.8. Shall we give it a go? Let's give it a go. Obviously, touching anything that's got mains connected to it is incredibly stupid. You'll die instantly. You'll just be vaporised. I hope you like crisps, because you're about to become one, and all that. So never do it. Don't do what I do. I'm a professional idiot, trained, all that fun stuff. Right. We're at 43.74 currently. Turns it up. And that turns it down. So the max I can turn it down to is 42.5. And the max I can turn it up to is 46. I'm going to be honest, 42.5 is actually kind of close enough. Yeah, I can't get any more turn out of that. That's what we're getting. It's a difficult one. I'll talk to the customer and see what they think. In an ideal world, you do not want an output of more than 42 volts, because it could overcharge the cells. Overcharging the entire group of cells by half a volt on a healthy pack, not that much of a problem. Let's say you had a faulty pack and a faulty BMS. Well, you'd have bigger problems then, wouldn't you? It's a difficult one. It's trimmable, at least. It's down a bit, and that might be the answer there. So let's see. Anyway, this pack is rebuildable. I could either use the existing BMS and cell setup and make it this weird 12S, but it only charges up halfway, because this would never charge up fully. 12S would be, well, not that fully charged. It'd be 12 times 4.2, which is, 48 volts, not 43 volts like it thinks it's putting out. So it's very bizarre. Yeah, I'll see what the customer wants me to do, because if you can just replace this with a 36 volt battery, you should, instead of using a 48 volt battery that's never fully charged, because it's just dumb. I don't know. I'll talk to the customer and hopefully I'll film the next part. Okay, so I thought let's do a little bit of testing. I've just watched a YouTube video on a guy doing a similar thing. He stuck a hoverball battery in it and it worked fine and thought it had a full battery. So it probably is rated for 10-ish voltage. What I thought I'd like to do though is see, apparently on the main board here, no, that's the battery. Hold on, I'll get there. There's a brain in here. This port here is for an RS232 connection, just there on the side of the BMS, but this lower serial model unit doesn't use that. And then on the main board here, I believe it would have plugged into here for an RS232, and it doesn't use it, this one. So actually, I've got a good one, an easy one, and it seems to just sort of work without it, which is nice. That's what we like. So if that was a 36 volt 3.4 amp hour lithium battery, that would be 10S 2P, which is 20 cells. Now, I count in here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 cells. If we stick top of the range moly cells in this, they do a 2,800 milliamp hour cell, so 2.8 amp hours each. We can upgrade this to a 5.6 amp hour, nominal, battery pack in exactly the same size. Actually lose a bit of weight because we'll be using 4 less cells, because we only need 20 cells, so 5 lots of 4. Well, 10 lots of 2. We don't need these extra 4 here. We'd replace the BMS with a new one, keep it all in the same sort of form factor, and just off to the races. And it's just power in, power out, which is great. So it's basically a bog standard e-bike battery pack. What I would like to do is just double check the voltages that we're working with here. So I'll get the cage, the battery cage, plugged back in. 2 things. That way up, and let's have a look. So our comms light. This appears to be for a communication port that we're not using, so that's fine. Don't need the charge connector hooked up. Let's go for on-off switch and battery power in. We've got to remove that from this unit here. Didn't think about that, did you? Because I think I'm going to struggle with wire lengths and things to get hooked up to that comfortably. I think going to be a rough pain in the cheesy what's it, but that's fine, not a problem. I will get this cut off or desoldered, or what do I need to do to test it. So we obviously want the red and black wire off here. I could probably desolder that one, and then this one I'm going to struggle to desolder easily, so I'm just going to give it a snip up there, cutty. Ugh, I'll just cut it. Oh, maybe I won't, maybe my soldering iron's heated up. Off it comes. There we go. So I'm going to use this in place of the battery pack, and I'm going to get my adjustable voltage power supply. That should go in that way. Yep, lovely. And we're going to hook up to that instead. So let me just, everything is on the workbench today, all at the same time. It's really good, really helpful. It's great stuff. Right, let's turn the power supply on. We are at 9 volts currently, so that should be nice and low. Good safety and all that. Bang, little bang, tiny bang. Okay, so it'll probably give me an error if the halls aren't connected. So let's connect those up. And don't let that short out. Onto there. Oh, we're losing our little rubber grommets. They are departing for the held the battery mount in place. Keep them. Right, let's turn it on. So it won't power on at 9 volts, but it will power on at 9 volts. So it's complaining of a low battery. Now a lithium battery, a 42 volt fully charged, should be about 30 volts dead. So if I wind this up to 30 volts, we should get low battery. Off and on. Draws about half an amp. Not half an amp, sorry, 0.05 amps. So, as I wind this up from 30 volts up to 42 volts, I'm hoping to see this climb. .34 volts, ideally, we should be seeing more than 1 bar of battery. Yes, very loud beep, yep. Not quite, okay. Let's try 36 volts. That should be more than 1 bar of battery. Nope. Okay, 38 volts. Still on 1 bar. 42 volts. Full. Right, so I'm wondering if the battery indicator is not very accurate, because that is not great. Right, let's wind it down. 41 volts. Full. 38 volts. Empty. How can it have a working voltage of that? It's terrible. 39.8 full. 39.14 half. Right, so I think that the battery connector is probably really useless. Connector display. I think the display is horrifically inaccurate, because what's that? That's terrible. Down at 34 volts, it's just going to think it's empty. Yeah, right, okay. Fair enough. Well, that's information I need to relay back to the customer, because if I change this round and it always says it's got low battery, that's going to be really annoying. I'm loath to reuse this weird battery config of a half-charged pack like this. It's very strange. Very, very strange. Okay, I've got no idea where I left this, but this is the pack. I've got my new cell holders ready and new BMS ready. So what I'm going to do is get my lovely Samsung 30Q cells and pop them in. So I'm going to start off as they did and do, well, I'm doing 10S2P, then not. I don't know why they didn't, but other people on these other videos have used hoverboard packs without problem. Therefore, hopefully it's all going to be fine. I chatted to the customer, he said it's worth a shot, because a new battery pack from the company that makes or provides them, or whatever you want to call it, costs a huge amount of money. So he's happy to give this a shot for considerably less, for just a teeny weeny little battery pack like this. I do apologise that you can probably hear notification sounds in the background. Being filmed on the phone at the moment because my normal thing is broken. It's a whole thing, but you know, here we are. So that's cells in cell holders. I have put some insulating rings around them already. You don't need to watch me do that. It's really boring. And that way or that way? That way. Just going to fit on there. Like that. I've got these lovely, for when I'm building these small packs, because occasionally I'll do a little conversion kit that goes on the front of someone's bike, and this goes inside a little bag on the handlebars. The controller goes next to it, very much like a switch kit bag, except less tidy, but also costs far less. I can just build up one of these little packs and then wrap it, stick it in the bag, controller next to it, pedal sensor, front hub, boom, bike converted. So this is the kind of thing I'd build, and I'd use 30Qs or Molicel cells or something like that, something nice, you know, to build those up. So what I've got then is, oh, loose, get back in there. I've got to cut some nickel, which will be scissors, 2 little strips. Let's have a go at this then, shall we? 2 little strips for the pos, 2 for the neg. They're done in kind of an annoying fashion, but I guess that's what we're going with. Wait, my neg and my pos are backwards. It's because I was building that way round. There we go. Do I actually want to put you that way up? Yes, I do. That's more like it. I could do that and double it back on itself. That's what I could do. I don't really want to solder to the top of the cells. It's not for me. Another one of those, and you can go straight off on a tab. That's good. And then we're going to join these 4 together with another bit of nickel strip. Like that. One of those, and if we flip them both over, they're all easy peasy. Right, so let's start off with this one. Using my do create, whatever you want to call it, spot welder. It's super handy. Gives nice reliable spot welds. If you can deal with letting the thing charge up all the time, of course. I had a bit of a problem where I couldn't get welds to stick on a previous battery video I did, but it turns out that inside the bit here that you loosen off to get to the tip was not done up properly. Try to put you in the middle of the frame, be nice, wouldn't it? And I sort of opened it up, cleaned off some oxidization, and now it's all working fine like it should be, which is really nice. That's what we like. I'll go for a third. That's about what on these. Just to make me feel happy. That one's going to get folded over that way. This one isn't. That one's going to get folded over that way so that I can spot weld my positive onto it without getting the cells really hot. And then we want cell holding nickel. Is this stuff? There you go, it's this stuff. 1, 2, 3, 4. No. Maths. Hold on. You're joined to there, you're joined to there. Oh no, have I done this wrong? I've done it wrong. Wait. Oh no, I'm so stupid. No! I'm done. Because that should be joined and that should be joined, and this needs to be on the other side. Oh, bugger. I can fix this though. I can fix this by joining those together and just cutting these off or ripping them off. Ripping them off. That's what I can do. That's what I can do. Okay, I'll start building up the pack with my nice Samsung 30Qs, and I'm just replicating their what do you call it? Battery system. Replicating their pack. So I'm going to cut it. 3, 4 of those for this side. 1, 2, 3. Is that only 3 I've cut? I've only got 3. It's been a very long day today. Make that 4. It's a bit more like it. Go that way or that way? Let's go this way. And let's get all these spot welded up. Oop, I missed a bit there. Like it. I'm using my Docreate, I don't know how you say it, supercapacitor spot welder, which is super good for building these smaller packs. It's just quick, it's easy, the probes don't get that hot that quickly, it's reliable, you get a very consistent weld. All the time you keep the voltage above, like a 4.7 volts on the little screen on it, which is nice. So we've got to have then that one joined together, that one joined together, 1, 2, 1, 2, yep. So I need 2 little nickel strips. Let's put one there like that, and with a little tab, because we're going to fold that over. And we'll put one there with another little tab that we're going to fold over. And then we want this size nickel, 4 more bits of this large ladder. 1, 2, 3, 4. And I think I should move these stray bits away because it's a bad idea keeping them close by. Don't need that, don't need that, don't need that. So our 4, don't want that bit, we're going to go across these, on there, on there, on there, and one there like that. Yeah. That's why you're not going to put them all in place first. Sticky fingers. was an interesting place, wasn't it? 2, 3, 4. Now, I don't want to wait to spot weld these on because this will need charging up, but I'm going to get a different one. I've got one of these cool little doodads that I have modified with a little fan on the top and done some nonsense inside it to swap that out, and this will give me a nice strong spot weld. Doesn't want to come off, that's good. For the non-cut and thicker nickel strips like this, it's just way quicker for me to get this thing out, especially when there's only 4 of them. And if you're going for prettiness of spot welds, obviously these tips are a set distance apart, and they always give you exactly the same bit like that. That's our pos tab, that's our neg tab. BMS can go up there, that way round, which we're going to hold on with some lovely sticky tape, some super sticky tape. I normally put one bit sort of halfway down there, like that. Get my little pen, pop them off there. Get my other bit, and I think you can just tear this stuff. And this is just some sort of thick foam backed double-sided tape, which is great for keeping the BMS off the cells, because BMS can get warm, cells can get warm. The less warm you get things, the better in my book. One like that. Soldering iron's not on, is it? I'd love to tell you where you can get these, but they're I don't think they're for sale anymore, unfortunately. But in there's a great big Life PO4 cell, and a really handy little thing to keep around.
So what keeps happening is this phone that I'm using to film currently keeps overheating, which is it's great. It's really good. I'm happy about that. So very happy about that. I've just realised there's customer information in this whole thing. I'm gonna have to learn how to blur now, aren't I? Oh.
Okay, so I filmed this about 5 times. So I built the pack, and then my spot welder was playing up, and the spot welds didn't stick, and I thought I'll film it again. And then I filmed it again, and then I realised I had customer information in the whole thing, which was great. There was just a sheet sat right there, just all their information on it, like a fool. So I have removed it, and now I'm not showing you the pack building process, although I swear I did just build it, because look, there's nickel off cut and my spot welder's on, and I even got out the second spot welder. But here we are. Oh, and the phone that I'm using temporarily keeps overheating because it's on charge, because it's got no battery in it, and there's a wire plugged into it. It's right underneath the light, and it's getting too hot, and it keeps telling me it's too hot. I'm turning it off. Anyway, Samsung, I've said this so many times, lovely Samsung 30Q pack. I've just stuck the BMS on. I did cut all the nickel and spot welder up in front of you, but you're never going to see it because I don't know how to blur things. So, here we are. I've just got to solder on the balance leads and get it all put together now. It's very exciting, very fun. And I'm going to do my normal horrible trick where I'll make the balance leads all the same length and then tie up the slack over here in the excess space I've got in a horrible bundle that upsets people because they want the packs to be the prettiest thing in the whole wide world. And they can't stand it when I do anything different. So that's fun. It's going to be enjoyable for people watching. They will love it, I'm sure. Oh, hot. Just tin these up. Ready for me balance wires and my power cables. I like to go slap bang in between the two groups, or if I can, I'd go on the neg bit there, but for vague neatness, I would like to not. And then we'll just start at the negative end, go round, and we'll solder the end on. This one. Then we want the second one. Is that one there? Which is going to end up being, hold on, big on this side, over there. And do I want it to go all the way round? I could have it go all the way around, couldn't I? There'd be nothing stopping me. Is that what I want to do? All the way around and tie this slack up there, or up and along? Up and along is the answer to this. There we go. And then next one comes over here. That's going to go, you guessed it, up and along onto the next one. And then flip it over. Get the next balance wire and flip it over again, and then we go on here and then flip it up, get our next balance wire, stick it over and solder it on. You get the idea. It is truly riveting stuff. I apologise about the notification sounds that you're hearing. Turns out I didn't silence it. I'm a fool. And then there's this one. And then flip it over. And then get the next one. And flip it over. And these ones are going to come off the bottom. Flip it over and get the next one. Flip it over. It's very exciting, this, isn't it? Oh, I've crashed. And flip it over and get the next one. And flip it over and solder. And flip it over and get the next one, flip it over and solder, and then the final one, and flip it over and solder. So all our balance wires are hooked up now, and what I'll do is I'll get them vaguely pretty. So stick them down where I can. Got the option to stick them nicely. I'm going to do something a little bit nice-ish. Something like a little bit like that, and then I'll stick a bit of tape over here to keep them in place. If my nails didn't just snap off, I'm sure that's a sign of, great, I'm sure that's a sign of something, some kind of deficiency, something wrong with me. Who knows? Those ones, and then these ones. I'm going to go for a bit of that, and a little bit of that, and a little bit of that, a little bit of that, and then a little bit of that. if I can grab enough fingers, I can just hold them all in place nicely. And they can sit kind of like that. A lot of people will have a bit of an uproar about having balance wires. Oh, I don't have enough fingers. Having balance wires anywhere near the sides of a cell. My opinion is that balance wires are so tiny that if one ever did decide to short out, it would be a tiny little puff of smoke. Nothing would happen. The balance wire would melt. It's essentially like a fuse wire. There's a reason they're made very little, because they don't carry any current. Why is the bit of solder stuck to the side of my knife? That's my opinion.
Oh look, we overheated again, what fun. Yeah, that's my opinion, and I am entitled to it. So I'm going to keep having it. I'm going to have to probably cut this now, because with the I've overheated again problem that this phone's doing, it won't let me record again for another 5 minutes, and next time we pick up, I'll be closer to done.
Okay, we're going handheld for this last bit. Excuse this is a separate battery and charger situation. It's a Vengeance battery that wouldn't work, so I've replaced the BMS. And this is our pack. So I've got to obviously dress it fully. I tested it, and it tested at like 5.9 amp hours at 10 amps discharge, which is perfectly fine for what should be a 6 amp hour pack. And I've got it hooked up here to the charge port on the SmartDrive. And the power port is here, and if I plug in said power port, will it reach? I don't like doing this one-handed, but here we are. Should go pop as I plug in for the caps. Oh, it's still charged, okay. And then turn that on. We will see, chasing LEDs, and then battery level. So, that says, move that out of the way. Okay, look, we've got one light on. It is charging. This is the charger. Charging. That's the charge connector there, the magnetic jobby I showed. Yeah, before, the Rosenberger connector. That's clicked off charging. And then when I plug it in, that goes red. So we're all good to go. I'm going to put this back in there. Obviously, I've got a fish paper and might reuse this piece actually, fiberboard around it, and it'll be all good to go. Thanks very much for watching. If this sort of thing helps you out or gives you any kind of useful information, please leave a like rating. You can comment, subscribe, become a channel member, something like that. And yeah, I will see you next time. Thanks. Bye bye.